Hi, my name is Timothy Boardart, and today I'll be continuing to talk about foundations, specifically foundations for high-rise buildings. To begin, I'd like to recap the Millennium Tower, the skyscraper that I've been talking about for most of the semester. For those of you who have forgotten, the Millennium Tower is a 58-story skyscraper that opened in April of 2009. The skyscraper was meant to be home to many luxurious condos in San Francisco. Although since opening in 2009, the skyscraper has been the center of a major settlement dilemma. The skyscraper has sunken 21 inches and has over 14 inches of tilt to the northwest directions since opening in April of 2009, which is a very bad look for the engineering company. The economical impacts that the settlement has had on the Millennium Tower are astronomical. The condos are depreciating at an extremely high value. The luxury condos that ranged in price from 1.6 to $10 million apiece have lost an average of $320,000 a unit, and several well-known people have begun to sue the Millennium Tower for this certain reason. Specifically Joe Montana, the former San Francisco 49ers Hall of Fame quarterback. In my last technical presentation, I talked about using micropiles to stabilize the foundation of the Millennium Tower. That is because the Millennium Tower shares a lot of similarities with Mandalay Bay and its sinking structures. And Nicholson used micropiles to stabilize Mandalay Bay in the late 1990s, and it worked very well with him, and there has been no problem since then. Therefore, through the use of the grout and the steel casing, it would be the best solution for the Millennium Tower. And frankly, there aren't a lot of other options. My thought process is the best option would be to tear it down and build it from scratch and build it the right way. But that's not necessarily an option, considering it would pretty much guarantee the project non-profitable. However, the rest of the presentation today, I'm going to be talking about different methods that can be used so we can prevent settlement in foundations for these high-rise buildings, because it is a very big challenge in today's engineering with the growing popularity of these structures. Moving forward, the options we have for foundations for high-rise buildings depend heavily on the soil of the ground below the foundation. A few of the options we have moving forward for high-rise buildings include raft foundations, drilled shafts, and then compensated pile raft foundations. A few examples of raft foundation in these high-rise buildings would include the Millennium Tower, where, as I've illustrated throughout the semester, it did not work out very well. But a different example would be the Space Needle, in which case it has worked perfectly fine for the last 60 years. After its construction completed in 1961, the mat of the foundation for the Space Needle was 30 feet deep by 120 feet across, and after all the cement was poured into that hole of a foundation, the foundation weighed just as much as the rest of the Space Needle, and the center of gravity was established just 5 feet above ground. An example of drilled shafts being utilized in the foundation for a skyscraper occurred in 2014 when Malcolm Drilling installed 44 drilled shafts to support a foundation in San Francisco. These shafts averaged 262 feet deep and were drilled down to the bedrock. I find this story kind of ironic. Just 5 years after the Millennium Tower opened, another company was installing shafts down to the bedrock in San Francisco to support their building. And the Malcolm project manager said that on the job, their problem wasn't getting down the bedrock, it was operating within the very small working area that they were given in the heart of San Francisco. As you can see in that picture there, there's a lot of equipment needed for the job. They got their big drill there by another excavator, and then they have a huge crane to help pick up the casings and the cages and everything else that goes into the shaft. Another problem they had was getting the cages to the job site. The 262-foot cages were brought to the job site in 3 sections and then were welded together as they were brought down there. And those cages are extremely important to the shaft because that's what gives the concrete the strength. However, Malcolm got the job done, and there's been no reported issues with the building since the construction has completed. Last but not least, we have piled raft foundations, which are becoming increasingly more popular for the high-rise buildings because they include a raft and then they include a pile, which is similar to a micropile, but they're usually much bigger. The micropiles are about less than a foot in diameter, and most of these piles that are installed underneath the rafts are at least a meter in diameter, sometimes 1.5 meters in diameter, and this allows for the raft to not have to support the whole structure, and it allows for the piles to take some of that pressure off the raft and distribute it through the soil as well. So some popular projects that this was used on, I'm sure everyone has heard of the Burj Khalifa in Dubai. It's currently the tallest building in the world. It's 828 meters tall, about 160 stories, and there was a lot of difficulty when constructing it because all the sedimentation underneath is very weak. The entire sedimentary column is full of either weak sandstone, weak limestone, or silty sand. And so the solution was they built a 3.7 meter thick raft, and then they used hundreds of piles underneath it because if you don't know, the structure of the Burj Khalifa is kind of like a triangle, and so there's more piles that are focused underneath the points of the triangle to help take the load off of the structure itself. And so those piles were 1.5 meters, and about 50 meters below the raft is how far they extended into that weak rock or limestone. And another struggle that they also had besides the weak seg column below it was they also have very strong winds in Dubai because of how flat it is. And so they also had to take into account that when they were constructing it. Another example would be in Saudi Arabia, in Jeddah. There's a tower that's about the same size as the Millennium Tower, but it was built on karstitic limestone. And for those of you who don't know, that generally leads to rock cavities below the structure. And so when they were building on the fractured rock, they didn't exactly know what they were going to use for their foundation. So they as well ended up using the raft pile foundation. And so this allowed for better load distribution because the rock cavities below the surface were unknown to the engineers and such. So when they were constructing it, those piles allow for the redistribution of the load if they were to hit a rock cavity. And so they used 145 of these piles and 1.5 meters in diameter, just like the Burj Khalifa did. But these piles were 10 meters shorter. They were only 40 meters long. But the raft that they used, or the mat for the foundation, was 5.5 meters thick. So it was almost 2 meters thicker than what was used in the Burj Khalifa. And neither of these structures have had any problems with settlement since they were constructed. And so therefore, I think moving forward with the construction of these high-rise buildings, that we should definitely look towards the piled raft foundations because, I mean, if the tallest building in the world used this and it has no problems, I think it is clearly the best option. And we don't want any more failures like the Millennium Tower. And with that, I'll open up for questions. Thank you very much.